Okay, let's get started with this. This is section 5.1, Understanding Linear Functions for Integrated 1. So today what we're going to be doing is starting chapter 5, which is all about linear functions. The main objective of today is to be able to identify what a linear function is. Okay, and that's why the essential question is, what is a linear function? So we're going to figure out if something is linear or if it's not linear. So anyway, let's get started with the first part. So as always, I've went ahead and highlighted the essential question, what is a linear function? Like I said, that is the main goal of today, that you guys will be able to identify what is linear and what is non-linear. Okay, so let's get started with this part right here first, recognizing linear functions. Okay, if I give you a graph, you will be able to tell if it is a linear function because the graph of a linear function will always be a non-vertical, vertical means straight up and down, right? That's vertical. So non-vertical, so it doesn't look like that. Non-vertical straight line. The missing word there is line. The graph of a linear function is always going to be a non-vertical straight line. So for example, the one right here, given to you guys, there is no line connecting them, but you can see how the points are arranged on a straight line, right? If I were to connect them, they would make a straight line. It's not vertical, so as long as it's not vertical, it's okay. It's considered a linear function, and it is a straight line. That's how you can tell from a graph. Now, from a table, it's a little bit different. From a table, a linear function, what you look for is that it has a constant. Constant means that it doesn't change, okay? That it stays the same. So a linear function has a constant rate of change. So now that's kind of a contradiction, right? I just said constant that doesn't change, and it's a rate of change, so it's changing, okay? What we mean by this is that it's changing at the exact same rate every time, okay? The rate of change does not change, is what I'm trying to say. So this will change into this will change into this will change into this, but it'll be the same number every time. So here's how you check from a table. Check that the change in y corresponds to a constant change in x. So what you need to do for a table to see if it's linear is to check how the numbers are changing. And that's what I'm going to do right here. Watch. Let's start with this side because it looks much easier. How is this changing? From 1 to 2, what happened? It went up, right, by 1. It's plus 1 from there to there. From 2 to 3, plus 1 again. From 3 to 4, plus 1 again. From 4 to 5, plus 1 again. Notice that all of those are changing by the same number. Okay, that still doesn't prove that it's linear. I have to check the y values also. So we're going to check the y values to see by how much is it changing. So from 210 to 420, you added 210, correct? From 420 to 630, you added 210. From 630 to 840, you added 210 again. And from 840 to 1050, if you check what's the difference there, you added 210. And so you can see that the rate of change for the y values corresponds to a constant change in the y values. Basically what you're doing every time to check the rate of change is to divide the numbers, okay? So which is we're gonna be doing with a lot of different tables. But this one's pretty obvious. This one is all changing by ones. This one is all changing by 210s. This is considered linear. As long as this number keeps being the same and this number keeps being the same, it's gonna be linear. Let's do the same thing for this one. Let's start with the x values over here. From 1 to 2, it's plus 1. From 2 to 3, it's plus 1. From 3 to 4, it's plus 1. And from 4 to 5, it's plus 1. All plus 1s. For the y values, from 1 to 4, it's plus 3. From 4 to 9, that's plus 5, right? It changed by 5. From 9 to 16, that's plus 7. And from 16 to 25, it went up by 9. So you can see here, the change in the x's is constant, but the change in the y's is not constant. 3, 5, 7, 9. It did not change by the same value every time. This one is non-linear. We call it non-linear. Where this one is linear. That's how you tell, by looking at the rate of change in the x's and in the y's. It must be the same. It must be constant. That's what we mean by constant. It must be constant for the x's as it is for the y's. This one is constant for the x's, but it's not for the y's. Therefore, it's nonlinear. Okay, let's move on to the next section. Graphing linear functions given in standard form. Okay, so first I'm going to define what standard form is, and then we're going to attempt a little bit of graphing when a function is given in standard form. So here's standard form. Standard form of a linear equation. ax plus by equals c. I want you guys to highlight that. And also highlight the word standard form. Standard form of a linear equation. ax plus by equals c. This is what's considered the standard for any linear function. They should look like this to be considered standard. There's an x, there's a y, and the x has a number next to it, and the y has a number next to it. And then there's a constant number over here on the right side with no variable next to it. Okay, there are two variables in this equation. There's an x and a y, so two variables in the same equation. We haven't really looked at variables at equations with two variables up to this point, but this one has two variables, the x and the y, but no variable here. A, B, and C just represent numbers. So for example, this is a standard form. I'm going to just write a few to show you guys what they look like. 2x plus 3y equals 5. That's standard form. There's the x, there's the y, a number next to x, a number next to y, and a constant on the other side. They don't have to be whole numbers, by the way. I could make this one up. 1/2 x plus 4y equals, and they don't have to be positive either. I just put a negative there. There's the x, there's the y, there's a number next to x, which we call the coefficient, 1/2. There's a number next to y, which is 4. Here's the coefficient. And there's a constant on the other side, which is -7. Right? So A, B, or C could be positive. They could be negative. They could be fractions. They could be decimals. Here's another example. 0.2x minus 15y equals 0. That works. Here's x. Here's y. The number next to x is 0.2. The number next to y is -15. The constant is 0. 0 counts. Okay. The only exception is if you have a 0 next to both the x and the y. You can't have that. Okay. But you can have a 0 next to x and a 0 next to y, but not both at the same time, because that just eliminates both of the variables. So this is a standard form. This is standard form. This is standard form. All of those are considered standard form of a linear equation. Here's another one. X plus y equals, 1. That's standard form. There's the x, there's the y, and you might say, well, there's no number next to it. Yes, there is. If we don't write a number next to it, it's a 1, right? So it's a 1x plus 1y equals 1. So in this case, the a value, the number that is next to x, is 1. The b value, the number that is next to y, is also 1. Okay, so this is also standard form. Standard form, standard form, standard form. What do you look for in order to tell that it's standard form? Look for x and y separate from each other, right? They're not being multiplied times each other ever. They're being added or subtracted from each other. And also, they shouldn't have any exponents. Notice that it's just x and just y. It's not x squared or x to the third power or anything. There are no exponents on the variables. If there are, then it's not linear. So what we have learned before is that equations have solutions, right? So these equations, linear equations, have solutions also. But since there are two variables, that means that the solution has to have two numbers in it. So what do we consider the solution of a linear equation? And by the way, we say the solution of a linear equation in two variables because it's an equation that has two variables. The solution of a linear equation in two variables is any ordered pair that makes the linear equation true. I'm going to erase all of these so we don't get lost in all the mess that I've made. So any ordered pair that makes the linear equation true is considered a solution. So what does that mean? An ordered pair, guys, let's write it right next to it, is this. This is an ordered pair, x, y. So a solution to these is not just x equals 5 or x equals 7 like we have done for previous equations. A solution means two numbers, an x value and a y value. If it makes the equation true, it's a solution. So like this one, let's look underneath. Is 2, 0, here's an ordered pair, is this a solution of 5x plus y equals 10? How do we know if it's a solution or not? We're going to test it. The first number represents x. The second number represents y. So we're going to take these two numbers and we're going to plug them in right there to see if it makes the equation true. Okay? If it makes the equation true, then it is a solution. If it doesn't, then it's not a solution. So let's do that. I'm going to write it like this. 5, leave parentheses open for x, leave parentheses open for y. In those parentheses, I'm going to plug in the correct number. So for x, I'm going to plug in 2. And for y, I'm going to plug in 0. So 2 there and a 0 there. Simplify it. 5 times 2 is 10. 0 is just 0. Is this true? Yes, it is. Therefore, we're going to say yes. Yes, it is a solution. 2, 0 is a solution. Is there only one solution? No, there could be more. Like, for example, let's test 1, 4. Maybe it is a solution, maybe it's not. So I'm going to do the same thing. I'm going to take my equation, which is this one, and write 5x, but instead of x, I left empty parentheses, plus y equals 10. So I left empty parentheses for x and for y. We're going to plug in x, which is 1, and y, which is 4. Simplify it. 5 times 1 is 5, so that's just 5. Plus 4 equals 10. Oops, I put 0. I mean 10. Is this one true? And obviously no, right? That's a 9, so no. Oh, I messed up again. No, this one is not true. Let's put an X there to show that it's not true. So is 1, 4 a solution? No. But does it have other solutions? Yes, it does. It could have many, many, many solutions. So we found 2, 0, but there could be many more. And I'm sure you guys could come up with different values that would also make it true. I could make the x 0 and make the y 10. 0, 10, and that would be 10, right? 5 times 0 is 0, plus 10 equals 10. And there could be many, many others. There isn't only one solution to these. There could be many. What we have to remember is that the solution is two numbers, an x value and a y value. Right, let's move on to our first example, number 1, which is right there on your notes. The instructions say, determine whether the equation is linear. If so, graph the function. So first we got to determine if it's linear or not. And once we determine yes or no if it's linear, we're going to graph it. So first what I'm going to do is just look at it and see, can I tell just by looking at it if it's linear? The answer is yes, I can tell because this looks just like the standard form that we learned about here, right? Isn't there a 5x plus y equals 10? That's ax plus by equals c. It looks just like that one. So look for an x and a y. Look that they're not being multiplied by each other, but they're being added or subtracted from each other. And also look that they don't have any exponents. So this one fits all of that. It looks just like those. So yes, this one is linear. So what I'm going to do next to it right here, I'm going to write linear to show that it is linear. And now we're going to graph it. To graph it, it is always going to be better if you solve the equation for y, okay? Meaning I want the y to be isolated. It's always going to be easier to graph it that way. So this one is not ready for graphing. I want to solve for y first. So if I want to isolate the y, this is something that we've done before. I want to isolate the y. That means you have to kick out the 5x. So we're going to subtract 5x. We're going to subtract 5x. That cancels, leaving you with y equals negative 5x plus 10. Do not combine the 10 and the 5x. That's a rookie mistake that you do not want to make. It's not 10 minus 5 equals 5. Okay? Since this one has an x and this one does not, they do not mix. So I write them separately. Negative 5x plus 10. That's what I got. Alright, now that I have that, I can graph it. What I'm going to do to graph is make a table. an XY table.
Daddy.
And on this table, I'm going to plug in some values of X that I want, okay? You choose the values of X, but always the best ones are going to be your most basic numbers that are close to 0. So -2, -1, 0, 1, and 2 are usually going to be your most useful numbers to use, okay? So those are going to be our common 5 that we use most of the time. So what we're going to do is, just like we did in the last sections, we're going to plug in this value, -2, in here, see what we get, and that'll be our output. Basically, our x's are our inputs that we're going to put into the equation, and the y will be the output, what we're going to get out. So let's start by plugging in -2. Here we go. I'm going to go y equals -5 parentheses for x, and notice that I always do that. I always leave empty parentheses so that I know where I'm plugging it in and I don't mess up. I'm going to plug in x, which is -2, so we're going to put a -2 here, and now I just calculate that. -5 times -2 is +10. 10 plus 10 is 20. I get 20 from that one. 20. Alright, let's do it again. Y equals -5 parentheses plus 10. This time I'm plugging in -1. -5 times -1 is +5, so y equals 5 plus 10, which is 15. There you go. That one's 15. Do the next one. Y equals -5 times x plus 10. In this one, we're going to plug in 0. So -5 times 0 is just 0, plus 10, that one's very easy, that one's just 10. Alright, we continue. Plug in 1. Y equals -5 parentheses plus 10. Right, the parentheses are for the x. We're going to plug in 1. That's the next one. Right there. So -5 times 1 is -5. -5 plus 10 is what I get. -5 plus 10. Check with your, be careful with your signs. You're adding two numbers, but one of them is negative, one of them is positive. So different signs. That means subtract. 10 minus 5 is 5. Keep the sign of the larger number, which is positive, so it's just 5. And the last one, 2. Let's plug in 2 and see what we get. Y equals -5 times x plus 10. Plug in 2. -5 times 2, that's -10, right? Positive times negative. So that's -10 plus 10. -10 and 10 end up canceling each other out and giving you just 0. So that last one is just 0. Alright, and now we're ready to graph. We're going to take those points that we just found on our table, these points right here, and we're going to graph them. So -2, 20. Remember what that means when you graph. It means on the x-axis, go to -2, so go to the left. On the y-axis, go up to 20, and wherever you find that point, that's where you put it. Okay. So -2 means left 2. Positive 20 means up 20. -220 is way up there. It's not going to fit on our graph, so actually I'm just going to skip that one. How about -115? -1, go to the left 1, up 15 also doesn't fit. Jeez, I think I made my graph too small there. That's why these are not fitting. Okay, 010. That one fits. 010 means 0, don't move left or right, just stay in the middle. 10 means go up to 10. So if this is 4, and this is 8, that means this is 6. 4, 6, 8, 10. It's right here at the tip of the arrow. That's where the first one is. 010. 15. 15 means go to the right 1 and then go up 5. So 1 to the right is right here in the middle because this is 2, right? 2, 4. So 1 and then up 5. 2, 4, 6. So we want right in the middle of this box right here. That is 15. Right here, approximately. Next one is 20. 20 means go to the right 2. And then 0 means don't go up or down, just stay right there on the x-axis. So 20 is right here where I have my point. So that's where I'm going to draw it. There you go. Connect those dots and you are done. I'm going to connect them like that. Well, that is not a right straight line, but you guys can probably do a better job with your pencil. That is the graph of this function. So it is linear, which is the first thing you check. See if it's in standard form. It is linear. Then I made a table of values. Actually, no, first I solved for y in order to get a table of values. Solved for y by subtracting the 5x. No rookie mistake here. I actually did the work correctly. Then made a table of values, plugged in a bunch of x values, see what I would get, and then I plotted those points. And that is your graph. And also make sure you notice that it is a straight line. Just like we said, it is linear. It makes a straight line. That's the first four letters of the word linear. All right, let's move on to number 2. Negative 4x plus y equals 11. By the way, I didn't mention this at the beginning. Make sure you guys are following me along on your notes, on your own paper. So make sure you're writing down everything that I write down. Okay, so negative 4x plus y equals 11. Same steps, same instructions. First, check if it's linear or not, and then graph it. So this one, I hope you guys can tell by now. Compare it to the standard form from up here, and you can see that it is linear, right? It looks just like that one. There's the x, there's the y, x, y, constant on the other side. Each one of these variables has a coefficient, a number next to it. Negative 4 for the x, and for the y, if you don't see it, that means 1. Okay, so the coefficient there is 1. But it is in standard form, therefore it is linear. This one is linear. Okay. That being said, let's go ahead and graph it. It's in standard form, and this is not a good form for graphing. We want it to be so that the y is isolated. We want the y to be by itself. So let's go ahead and do that. We're going to solve for y by getting rid of the 4x. To get rid of the negative 4x here, negative 4x, to get rid of it, we need to do the opposite of it. The opposite of minus 4x is plus 4x. So we're going to add 4x to both sides. When I do that, I am left with y on the left. And on the right, it's 11 plus 4x, or 4x plus 11. We usually write the variable first. So instead of writing 11 plus 4x, we write the 4x first, and then the 11, the constant, at the end. And again, we do not combine them together. That would be a rookie mistake. They are not like terms. So y equals 4x plus 11. All right, now what I'm going to do is make a table of values, an xy table, and see what I get when I plug in different values of x. Starting with the same ones as before, negative 2, negative 1, put them in a different color, negative 2, negative 1, 0, 1, and 2, and see what I get. Okay, I'm going to use a little bit more mental math here. I think you guys can follow me along. If you get lost, don't hesitate to pause the video and then continue watching. But I'm going to use a little bit of mental math. So first, let's plug in negative 2. Negative 2 goes right here. That's 4 times negative 2, that's negative 8, plus 11, negative 8 plus 11 is 3. That gives me 3. Watch again. I'm going to plug in negative 1. 4 times negative 1 is negative 4. Negative 4 plus 11, and that's going to give me positive, because the 11 is bigger, positive 7. Let's do it again for 0. 4 times 0 is 0 plus 11. That one's pretty easy. That's just 11. 1. 4 times 1 is 4 plus 11 is 15. And the last one, 2. 4 times 2 is 8 plus 11 is 19. So I can see from the graph that it only goes up to 10. Right, negative 8, but then it's negative 10, positive 10, negative 10, positive 10. That this one and this one are not going to fit. Well, 0, 11 technically also doesn't fit, but it's close enough that I can actually estimate where it's going to be. So we're only going to worry about those 3 points. Negative 2, 3. Negative 2 means left 2. 3 means up 3. So it's right here. Negative 2, 3. Negative 1, 7 means left 1. Up 7, right there. 0, 11 means don't go left or right, stay there, but go up to 11. Here's 10, so 11 is right there. There's your 3 points. You connect them together, and you get yourself a straight line, which was the goal. Again, I didn't draw a straight line. I'm having trouble drawing it with my stylus, but you guys could probably do a better job with your pencil. Alright, let's do it again. Let's move on to number 3. Hopefully you guys are getting the hang of it, and when I give you one to do on your own, you'll be ready for it. So here we go. First is to check if it's linear or not. By this point you can tell. Here's x, here's y. Each one has their own coefficient, no exponents, and there's a constant on the other side. So yes, it is linear. It's in standard form. It's linear because we can identify the standard form. So I'm going to solve for y. This one's a little bit tougher because the y is not by itself. Oops. The y is not by itself, right? There's a 2 next to it. Where in the last one, it was just y, so all we had to do is get rid of the negative 4x by adding it. Also in number 1, same thing. The y was just by itself, so all we had to do is just get rid of the 5x by subtracting it. In this one, the y is not by itself, right? There's a number next to it. So we're going to take care of it, but first, the same thing as before. We're going to get rid of the 6x. So to get rid of the 6x, I am going to subtract 6x. Subtract 6x from both sides. That cancels, leaving you with 2y. Once again, no rookie mistakes. We do not combine these two, so they're separate from each other. We write this one first because it has an x, so negative 6x plus 8. Next, we get rid of the 2 by dividing it out. We're going to get rid of the 2. This is an extra step from the other ones, right? The other one, the y was already by itself. In this one, there's a 2, so we got to get rid of it. We're going to divide by 2, divide by 2, divide by 2. When we divide by 2 here with the y, we got to divide both of them by 2, right? Has to be fair, so everything gets divided by 2. So the 2's cancel, leaving you with just y. On the right side, you have negative 6 divided by 2. That's negative 3x, right? Because the x is still there. And 8 divided by 2, that's 4. So plus 4. There you go. Now we can make a table of values to graph it. So let's draw a table of values, an XY table. Since I'm running out of space, I'm going to make it horizontally instead of vertically. Same thing, guys. It still works the same. And again, we're going to use mental math to solve it. You choose the x values, but really you should always choose these. Negative 2, negative 1, 0, 1, and 2. Using mental math, let's plug those in. So first, plug in negative 2 right there. Negative 3 times negative 2 is 6, right? Negative times negative. Negative 3 times negative 2 is 6. 6 plus 4 is 10. That's 10. Plug in negative 1, the next one. Negative 3 times negative 1 is positive 3. Negative times negative, positive 3, plus 4 is 7. To the next one. 0. Negative 3 times 0 is 0, plus 4 is 4. The last two, plug in 1. Negative 3 times 1 is negative 3, right? Negative times positive is negative. Negative 3 plus 4 is 1. And the last one, negative 3 times 2, we're plugging in 2. Negative 3 times 2, that's negative 6. Negative 6 plus 4 is negative 2. There you go. Those are your points, and we're going to graph them. It looks like all of them fit in this case. So here we go. Negative 2, 10. That means go left 2, down 10. So this is negative 4, so this is negative 2. Down 10 is right here at the edge. So negative 2, 10. Negative 1, 7. That means go left 1, down 7. Left 1, down 7. That means right there. 0, 4. 0 means don't go left or right. Stay in the middle, but go up to 4. Oh, did I just mess up? I did. Hopefully you guys caught that. I don't know why I'm doing negative 10 and negative 7. Right? It's positive 10 and positive 7. I should be going up here, not down here. So let's do that again. Negative 2, 10. That means left 2, up 10. Right there. Negative 1, 7. That means left 1, up 7. Right here. 0, 4 means 0, up 4. Right there. 1, 1, 1 to the right, 1 up, right there. And finally 2, negative 2, 2 to the right, 2 down, right here. And there is your line. Notice that the points are all in a straight line. All you got to do is just connect them. And there you go. And that's why it's called a linear function. It makes a straight line. Okay, so you can tell from looking at it that it makes a straight line, looking at the points that they're arranged in a straight line, or looking at the equation, which is the way we've been doing it. It's in standard form. It looks like a linear function. Okay, I want you guys to go to your side now and attempt number 1, just number 1 for now. Take the time that you need. Pause the video right now so you guys can go ahead and do it on your own, and then once you have done it, come and check your work because I'm going to do it myself here. But first, try it on your own first. Okay, try it on your own, and then you can pause the video, and then you can come back and see the correct work. Go ahead and pause the video now. Okay, here you go. This is the correct answer for number 1. It is linear. You should have realized that right away. This is in standard form, right? Ax plus by equals c. There's the x, there's the y. They're being added. The coefficient of each one. For this one is 6, for this one is 1. And there's a constant on the other side, which is 12. So it is linear, which is what I wrote right there. Next, what I did is I solved for y, right here. 6x plus y equals 12. That's the original. I kicked out the 6x by subtracting it, so minus 6x. Do not combine them together, so write them separately, right? Y equals negative 6x plus 12. Then I made a table of values for this. I chose the x values, negative 2, negative 1, 0, 1, and 2, and then I plugged them in, right? Negative 2 right here gave me 24. Negative 1 gave me 6 plus 8 plus 12, which is 18. 0 gave me 12. 1 gave me 6. 2 gave me 0. Once I had those, I went ahead and plotted them. The only ones that didn't fit were those two. 0, 12 technically didn't fit either, but I just wrote a point right up here, estimating kind of where it is. It's right on G, between G and R, up there on the word graph. And then here's 1, 6, and here's 2, 0. So then connected them together to make that straight line. All right, let's go back to my side. We're going to do the last 2 examples on that side, okay? Modeling with linear functions. Every time you guys see the word modeling, that means we're going to be using linear functions or whatever it is that we're modeling with to represent some real-world situations, okay? Some situations that could actually happen that represent real items. So, number 4. Well, first, the instruction says, graph each function and then give its domain and range. So remember what we said about domain and range. Domain is what are the possible x values. Range is what are the possible y values. Okay, so domain, what are the possible x values. Range, what are the possible y values. And also we need to graph them. So we're going to graph first and then we'll figure out the domain. Let's read the problem. It says, Sal signs up for a new video streaming service which charges $5 for each movie he watches. The amount Sal pays is given by f of x equals 5x, where x is the number of movies he watches. This makes sense, right? If he's paying $5 per movie and x is the number of movies, you can multiply by each other to figure out how much he's going to be paying for those movies. So if he watches 1, that's 5 times 1, $5. If he watches 2, that's 5 times 2, $10, and so on, right? So f of x represents the amount he will pay depending on how many movies he watches. So we're going to graph it. What I'm going to do is I'm going to create an XY table. We're going to choose some values of x that make sense. Every time you are modeling, meaning real world situations, you got to pick numbers that make sense. So for example, in the last problems, we've always been picking negative 2, negative 1, 0, 1, 2, and so on. Would it make sense in this case to choose negative 2 as x? Your answer to that should be no, right? X represents the number of movies. So when we put in negative 2 here, we're saying he watched negative 2 movies. That makes no sense. What is the lowest number of movies that he can watch? Well, technically 0, right? If he doesn't watch any at all, he can just do 0. So let's start with that. Although if he's signing up for the video streaming service, I don't see why he would watch 0 movies. He should be watching 1 or 2. But 0 is technically the lowest number that he can watch. And then he can watch 1 or 2 or 3. That should be good. Let's go up to 4. Why not? So 1, 0, 1, 2, 3, and 4. We're going to plug in those values into our function here. F of x equals 5x. So let's do it. F of 0, meaning plug in 0 first. We plug in 0 right there. What are we going to get? 0. That should be easy, right? F of 0 is 0. F of 1. Plug in 1. F of 1 is 5 times 1, which is 5. F of 2. At this point, you should be able to use mental math to get the rest. F of 2 is 5 times 2, which is 10. And so on. So 3 movies is going to be 15. And 4 movies is going to be 20. Right? Because it's $5 per movie. There's our values. Let's plot them in the graph. Now my graph does not have scales, so I'm going to make them up right here. On the x values, I'm going to go by ones. That makes sense. So that's 1, that's 2, that's 3, that's 4, that's 5, 6, 7, 8, and so on. On the y values, I'm going to go by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. Why not go all the way up there? And here too, why not? Let's go up to 9, 10, 11. Alright, we have a pattern basically set up, right? 0 movies, $0. That's the first point I'm going to plot. Right there. 1 movie is $5. 2 is 10. 3 is 15. 4 is 20. 5 is 25. Now, I didn't get that far on my graph, but I know by following the pattern that 5 will be 25, and the next one will be $5 more, and so on. 6 will be 30, because it's $5 each. 7 will be 35. 8 will be 40. 9 will be 45. 10 will be 50. 11 will be 55. There you go. There's my graph. Now it says find the domain and the range. Oh, first, should we leave those points like that, discrete, or should we connect them, which is continuous? Think about what these numbers represent. They represent the number of movies that he watches and how much he's going to pay per movie. This should be discrete. They got to stay like that. Actually, let's write that down. This is discrete. We should not connect them because it wouldn't make sense for him to say, I'm only going to watch half of the movie, so I should pay $2.50 instead. No, they're going to charge him the $5, right? He can watch, definitely he can watch the movies in partial amounts, but they're not going to discount him because he only watched a part of the movie. So those are the only possibilities there. 1 movie, $5, and so on. All right, domain and range. Domain means what are the possible x values? What are the possible x values? So if you look, x in all of these that we found was 0 for 0 movies, or 1, or 2, or 3, or 4, or 5, or 6, or 7, and so on. Could he watch more? Yes, he definitely can. Okay, so my domain is going to be 1, 2, oops, I skipped 0 for some reason. Let's go back. 0, 1, 2, 3, 4, ellipsis to say, keep going. Definitely no negatives, and also no decimals or fractions, right? He's going to have to pay for the whole movie no matter how much he watches. Range. Range are the possible y values. That's what range stands for, the outputs. So the outputs could be 0 also, 5, 10, 15, 20, and so on. Multiples of 5, basically. So starting with 0, 5, 10, 15, 20, etc. Keep going that way. No negatives and no numbers between 0 and 5. Only multiples of 5, basically. That's the domain. That's the range. Okay, let's do it again. Number 5. Elsa rents a booth in her grandfather's mall to open an ice cream stand. She pays $1 to her grandfather for each hour of operation. The amount Elsa pays each hour is given by f of x equals x, where x is the number of hours her booth is open. So if her booth is open for 2 hours, then the amount is $2. F of x equals 2, right? F of x stands for the amount, x stands for the number of hours. Now she pays, and since it's only $1 per hour, it's just basically 1x. That's what this means, 1x, but we don't write the 1. All right, so the first thing we're going to do is graph it, and then give its domain and its range. So we're going to graph it, f of x equals x. I'm going to make a table of values. This one should be pretty easy because it's f of x equals x. That's the simplest thing that I can think of to graph. We're going to plug in some values, again, making sure we choose numbers that make sense. How many x stands for the number of hours that her booth is open. So how many hours could she have her booth open? She could open it for 0 hours. That's a possibility. But also for 1 hour or 2 hours or 3 hours or 4 hours and so on, right? And this is actually pretty easy. Since f of x equals x, that means that it's only $1 per hour. The amount of hours is the amount of money that she's going to be paying her grandpa. So if she works for 0 hours, then she pays $0. 1 hour, $1. 2 hours, $2. 3 hours, $3. 4 hours, $4, and so on. Let's plot those points. Let's go by ones on this on the x-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And by ones on the y-axis as well. 3, 4, 5, 6, 7, 8, 9, 10, 11. So by looking at the table, I can see that they basically match, right? 0, 0, 1, 1, 2, 2, and so on. So I need to plot the points. 0, 0 means 0 hours, $0. 1, 1 means 1 hour, $1, and so on. 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10, 11, 11. Should I connect these? That is an interesting question here, okay? Elsa runs a booth that doesn't say she pays $1 to her grandfather for each hour of operation. The amount Elsa pays each hour. You know what? I'm going to say yes. It could also be no. For all we know, the grandpa says, no, you have to pay me for the full hour even if you only opened it for half an hour, okay? But he could also say, well, you only opened it for 30 minutes, so just give me 50 cents. Or you only opened it for 15 minutes, so just give me 25 cents and so on. So he could be that kind of person. We don't know. The problem actually doesn't tell us exactly how it works. So if we say discrete, if we leave it like that, then that means that she can only pay for full hours. If we connect them, then that means that she can pay for partial time. I'm going to go ahead and make it continuous, connect them, just to make it different from the last one that we made. But keep in mind that it could be discrete also, depending on how she's getting charged. Right? So either she's getting charged by only whole hour amounts, or her grandpa is saying, okay, you only opened it for a few minutes, so just give me a partial amount. Okay, so it depends on that. It stops here, but it does not stop there, right? It could keep going in that direction. The domain and the range. The domain are the x values. What are the possible x values? Well, starting with 0, it goes 1, 2, 3, 3, and so on. For the range, same thing. The lowest it could be is 0, right? The amount of money, the output. But it could be 1, 2, 3. Ooh, you know what? Let's fix this. I just noticed that I messed up on both of them. Let's erase them. I noticed that I made it continuous, right? Isn't it continuing forever? So 0, 1, 2, 3, and so on, that doesn't make sense for continuous. Okay, I need to write every single number that matches this line. Okay, and it's not 0 and then 1 and then 2, because it could also be the numbers in between. So how are we going to write that? We're going to write it like this. The x values in domain, that's the x values, are all greater than or equal to 0. And pay attention to why I wrote it like that. Okay, this that I just wrote represents all of the positive numbers and 0. including decimals, including fractions, all of the positive numbers and 0. Right? All the numbers that are greater than or equal to 0. For the range, it's actually the same thing, except instead of using x, we're going to use y. All the numbers that are greater than or equal to 0. So notice why I use this form instead of just listing numbers like here. Here I just listed numbers because it's discrete, right? It's only those numbers. Here I wrote it like this because it doesn't have to be just those numbers. It could be all of the numbers in between. So this is including all the numbers that are greater than or equal to 0, regardless of if they're whole numbers or decimals. Alright, now I want you to go to your side and do number 2. So like last time, take the time that you need, pause the video right now, work on it on your own first, and then come back and check my work, see what I did, okay? But first, try it yourself on your own. Go ahead and pause the video now. Okay, here you go. This is the correct answer for number 2. As you can see, I made a table of values right here. I chose 0, 1, 2, 3, and 4 for my x values. No negatives because this represents the number of umbrellas that Chris is selling. So he can't sell negative umbrellas, right? He can sell 0, no umbrellas, or 1, 2, 3, or 4. Or 5, 6, 7, right? It keeps going. For the y values, I got 0, 6 for one umbrella, $6, for two umbrellas, $12, and so on, 18 and 24. The domain is basically the collection of all the x values, 0, 1, 2, 3, 4, and continuing, right? That's what the ellipsis represents. By the way, when I say ellipsis, those are the 3 dots right here. That mean it keeps going. Range 0, 6, 12, 18, 24, and continuing. Here's the points. I graphed those, but of course it's going to keep going. And I did not connect them because it's discrete. We're talking about umbrellas being sold. He's not going to sell partial umbrellas, right? So he's either going to sell 0 for $0, or 1 for $6, or for 2 for $12, and so on. But he's not going to sell partial umbrellas and get a partial amount of money. Okay, and that is the last one. You guys are responsible for the homework, page 172, number 1 through 18. The last thing I want to say before I close this is notice that all of the problems that we did today are about linear functions. That was the whole point. They make a straight line, or they keep a constant pattern if you look at a table. They make a straight line and they keep a constant pattern if you look at a table, right? That is the whole idea behind linear functions. They make a straight line or they keep a constant pattern in the table. All of these, straight line, constant pattern on the table, right? The change in the y values and the change in the x values is constant. Straight line, constant pattern, constant change. All of these are linear functions, okay? And also you learn how to tell by looking at the function. It looks like a standard form, ax plus by equals c. Okay, see you guys tomorrow.